So we're going to do 1.1 key features of functions. We are going to get as far as we can in the notes today. You're going to do as much as you can of the homework, and then we're going to finish notes tomorrow, and you're going to finish the homework. Got me? That's how it's going to work. Most of this stuff, actually every single thing in this lesson, you guys have been taught before. It's been a while, so you might not remember it. But I'm just telling you it's not 100% new. So if you wanted to look, you could. So, the first slide you are not, why did that not work? The first slide you do not write anything on. We're going to talk. We're going to think. We're going to get kind of the concept is going on. So a diver is going through ocean search and rescue training. The graph is showing the relationship between the depth and the time in seconds since starting her dive. It says, what details can you determine about the dive from the coordinates of the point 5, -8? So what can you tell about this graph by 5, -8?
It took 5 seconds to get -8 feet.
Okay, at 5, it took 5 seconds for her to dive down to a depth of -8 feet. Okay, or dive down 8 feet. We typically don't say -8 feet, right? We just say dive down 8 feet. So it took her that. Anything else? Did she dive straight down? No, she didn't. She had an incline, didn't she? Okay. So what is the average speed of the diver in the water? So average speed is also known as rate of change, which is also known as slope. Okay, yes? Okay, so we can figure out the slope from the graph, can't we? Okay. Now, the last hour, they are like, well, we're just going to take 8 and divide it by 5. Okay, if you take 8 divided by 5, you get 1.6 feet per second, right? Okay, but you took x divided by 5. Well, isn't that slope? Yes. So that's what they did. They got 1.6 feet per second. Oops. Why is my pen not working? I'll try pairing it again. Everything's been like unpairing all the time today. Okay, so 1 feet per second. I know yellow is probably bad. Sorry. Okay, so, but let's actually count it. Okay. Well, this looks like it goes right to this point right here, doesn't it? Yeah. 2 seconds. Does it go right through 1?
Yeah.
Yeah. So that would be down 1, 2, and over 1.
2.
Oh, it's 1 because this is 1 and this is 2. So like each one of them down are 1 foot, but each over is a half a second. Does that make sense?
Oh.
Okay.
So,
So-
1.
Yeah. So it'd be -2 over 1, yes?
Yes.
So, but we're talking about an actual person, so we're not going negative feet or anything, right? So it'd be down 1. So we're going at a speed, because it says the average speed. Well, wouldn't that just be 2 feet per second? And then down. So I put it up here. I put it in the wrong spot. Why did we get 2 feet per second and they got 1.6 feet per second? Who's right? Us or them?
Us.
Why?
Because 2 times 5 is 8.
What?
Is that what we're looking
We're looking for the slope.
No.
for? Oh.
Why? Like we counted it and got 2. They did math and got 1.6.
How though?
They just took 8 divided by 5.
No.
Isn't slope y2 minus y1
Yeah.
over x2 minus x1? Yeah? Well, is that what they did?
Yeah.
No. Because
They just
that would have been fine if they started at where?
0.
0. Did she start at 0?
No.
No. She didn't start at 0. She started at what?
2.
2. So if they wanted to do that, they would have still had to subtract, right?
So theoretically, we're right.
They would have had to do 8 minus 2
Times.
over 5 minus 0.
Yes.
So which would have been negative 10 over 5, which would have been what?
2.
Negative 2, which what we got.
So we're right.
So we're right. But I'm just saying, when we are looking at things, do we need to look at everything involved? Yes. Okay, the last one said, which point on the graph shows the starting location of the diver?
2.
2. Okay, why?
Because that's what about.
That's where it starts.
Okay, well, that's where it starts, right? Why is it at 2? Why is it not at 0?
Because maybe she jumped. I don't know.
Jumped from what?
Boat.
A boat? A dock?
Something.
Right? She's not standing on the water and jumping in to save someone from the water, is she?
No.
No. She's standing on something. It might even be higher than 2 feet, but if she's training, they're probably not that high, right? They're probably at a dock. So we have to look at graphs. Graphs tell us so much information. I know they're one of our least favorite things to do, but they're actually one of the most valuable things in real life math when it's being used to analyze. The first thing they will do with data is they throw it into a graph because you can picture what's going on and you don't have to do any math other than graph it. So they're very, very important to analysis of things. Okay, so now we're going to start writing. Some of the stuff you will write, some of the stuff you will not write. Some of it you'll like, I need a little bit more detail. I used to have an instructor tell me, you write what I say, not what I put in front of you. Okay, I think you should write most of what I put in front of you and some extra stuff that I say. Okay, so domain. Domain is a set of all x values that give real solutions to a function. So, domain is what makes something real, makes it work. X values. So when we hear domain, we should think x values. We should think input. Isn't that also what an x value is? In science, it's called your independent variable, correct? So those things are all domain. Range is the set of y values that a function produces. Its outputs, its dependent variable. You've heard those two words before, correct?
Yes.
Ah.
Unfortunately.
I will tell you that domain and range was one of those things when I went through high school. I did it, and I kind of got it, but I never knew why. So anything for me, I always try to tell you why we are learning it. It is very important to know what values you can put in a function. Domain is really, really important. And I will tell you, unless you're dealing with a square, an even root, because we all know we can't take an even root of a negative number, or if you're dividing, because we can't divide by 0, correct? Other than those two situations, the majority of the time, if you just have an equation, the answer is all real numbers. That is the majority of the time. But once I put that into my diving problem, it changes. Okay? So if I go back to my diving problem, my domain is from 0 to the end of the lake. Okay? Why can't I be past that? Okay, it doesn't affect the information I'm giving, right? But this picture is actually all real numbers. This is an absolute value graph that we have. And its domain without a situation is all real numbers. But once I put it in a situation, my domain is from 0 to the end of the lake. Or whatever she's diving in. Does that make sense? So they are situational. Okay, domain and range, we say them in two different ways, or we write them in two different ways. The first way is set builder notation, and I will never call it set builder, I will call it set.
Do you want to strike that?
Your book will call it set builder, and it's the only time in math they're ever going to call it set builder. After this year, they say set. Okay? So you set builder and set are the same exact thing. I never say builder because it's weird. I feel like I'm Bob the Builder standing there doing stuff. Okay, so we have set notation and we have interval notation. And I will show you, I don't know if you want the words there. I'm going to show you what they look like. How about that? Okay, because sometimes the words don't mean a whole lot to us. It says it uses verbal description or an inequality described numbers. So if I say the domain is, so on set notation, I have these little squiggly lines. And if I'm talking about domain are X values, yes. So I have domain, this line right there, we say such that. And I'm going to say -9 is less than X, which is less than equal to 36. So that tells you that your domain is somewhere bigger than -9, because I don't have an equal to, correct?
Mm-hmm.
All the way to 36. Can it be 36? Yes, because it has a line under it, right? Okay, so then I'm going to give you another example. We have range in set builder notation. So range is the Y values, so you don't start with X, you start with Y.
This is gonna kill me.
No, it won't. Such that, we do it enough, it won't. It will just become second nature. Okay, Y. And we're going to say Y is less than equal to -10. Okay, so this tells me that all my Y's are equal to -10 or smaller, right? So that's where the graph is. Like the diver, whether our Y's were 0 to wherever the lake ended, right? So this would be the back half of that. Okay, so that is in set notation. I'm going to write the same domain and range, but in interval notation now. Okay? So I do want to, before I start that, when I have less than equal to, I have brackets. Okay? Brackets mean included. If I just have less than and greater than, I use parentheses. Remember graphing on number lines? Use parentheses and brackets. That's from that. Okay? So this domain up here that says -9 to 36. So it says interval notation is a set of real numbers and pair values from the minimum to the
Maximum.
max. So up here on my domain, what is the minimum? -9?
-9, yes.
So, and we usually just go D for domain. So I put -9, comma, and the maximum is 36. Okay, is 9 included? No. No. So do I use a bracket or parenthesis?
No.
Parenthesis. 36 included.
Yes.
And so I use a bracket. Okay, so these two are the same. One is in set notation and one is in interval notation. I use set every single time I do domain and range because we use intervals for so many other things. I like to keep my domain and range separate. But can you use set notation or interval notation? Yes. Your textbook, if you're working online, will say interval or set. Okay? You have to answer the way they say if you want to get it right. Got me? But on your homework, whatever you turn in, unless it says specifically, I will take it. But you have to know how to read both. Understand? Because some of them on the ACT will be in set, some will be in interval. So you have to know how to read both. So let's do the range. So what's the smallest range? It says everything is less than -10, right? So if I'm -10, that's everything to my left. Where does it stop? Negative infinity. So my minimum is negative infinity. So I have range. So I have negative infinity. And then it comes back to its biggest, which is what? Right here. -10. So can I ever get to negative infinity?
No.
No. So it can't be a bracket. It has to be a parenthesis. Can I get to, does this inequality tell me it can be -10? Yes, so it is a bracket. So the next slide is just a bunch of them we can look at without you having to write. Okay? So once you have this done, look up at me and focus. Everyone ready? Okay. So, we have on the left, we have interval. On the right, we have set. Got it? Their set, if you can't see it, but it's actually two little lines, but we just do one. This line right there, and I said it every time I wrote it, we say the word right there. When we say it, we say such that.
Such that.
Such that. That line means such that. Okay? So on the interval, it says it is from 3 to 4, and are they included?
Yes.
Yes, because we have square brackets. Now we say over here in set notation, x such that 3 is less than equal to x, which is less than equal to 4.
I forgot what is the line under it?
Equal to.
Okay.
It can be equal to it, so that's why we have the brackets. Addie, did you have a question? Okay, so the next one, we still have 3 to 4. Is 3 included?
No.
No, because it's a parenthesis. Is 4 included? Yes.
Brackets.
So we have
Yep.
x such that 3 is less than x, which is less than equal to 4. Okay, we have 3 to 4 again. Is 3 included?
Yes.
Yes, 4 is not.
No.
So I have x such that 3 is less than equal to x, which is less than 4.
That's how you have to say it.
Yes.
I don't like that.
But you would say this, the same thing.
Volleyball players are dismissed.
You would actually say
School volleyball players
3
are
is less
dismissed.
than equal to x, which is less than 4. You would say this the same way. At least this has all the stuff there, right? Okay, Addie, I will post the video. And the assignment is on Classroom. Okay, so the next one, are 3 and 4 included? Nope, so I lost both of my equal twos, yes? Okay, now this one, I'm going to tell you, I don't want you to write it like this. No, I'm teaching right there. Thank you.
That's me.
Bye. Okay, so this one says 3 to positive infinity, yes? Now, I will always put a positive or a negative. I hate it that you have to put a negative on the negative, but not on the positive. It's like infinity technically is either one, isn't it? So like I like to establish. So 3 is included, and I'm going to go to infinity. This is not how I would write this. Okay, so 3 to infinity, yes? X is greater than equal to 3. Isn't that much easier? I think it is. I think it's stupid to write what they have under it. There's a lot of like extra writing that I don't need to when all I have to do is say x is greater than equal to 3. If it's greater than equal to 3, that is every single number all the way to where? Infinity, without me having to write it. And if you're a perfectionist like I am, I spend 20 minutes trying to write an infinity symbol. Okay, so the next one says, oh, and also I did say, didn't I, that this is always going to be a parenthesis at infinity because we can't ever get there, right? Okay, so the next one we have negative infinity to 3. 3 is included. So you don't need to write it like this. All you need to do is say x is less than equal to 3. Okay, this I do want you to write down. I want you to write all real numbers equals a double-backed R. That is the symbol for all real numbers. Okay, so what is a real number? Is negative 10 a real number?
No.
Yes, it is.
What is that?
Negative. It's two lines. And make your R. So watch me, Cal. Make like a capital R, but just put 2 backs.
That's weird.
Okay, now, look at how they write it. You want to write it like that? No. All you have to do is say x such that x is a set of in the real numbers. That's it. What? Yeah, that's if it's from negative to positive infinity. Okay, A real number, if you want to write all those, they're in your book, they're in the PowerPoint, you can pause it at home, whatever. I'm not gonna take forever, it's gonna take a while. A real number is every number. Between 2 and 3, how many numbers are between 2 and 3?
A lot.
Infinity, yes? Because I can cut it to infinite number of times, right?
Yeah.
So every number has infinite numbers in between it. So the real numbers are huge. And I don't want to write to negative infinity to positive infinity. That is just weird. Okay? So okay, so what is the domain and range of the function? So in order to do that, we're going to talk about, first of all, what this looks like. It is squared. We talked about that towards the end of the year. It's a parabola, yes? Like a horseshoe. Okay. We will learn that this negative 3 moves it down 3. So I'm going to show you what it looks like. Just like this. See it? That's what it looks like. Okay. So mathematically, is there any limitation to what number I could put into x squared minus 3?
No.
There isn't, is there? So that means I can use all real numbers, correct? So my domain, and we'll do set and interval. Is all real numbers. So in set, we have the squiggly line x such that a double backed r is all real numbers. Now in interval notation, we're going to have negative infinity, comma, positive infinity, and are we going to use bracket or parenthesis? Parentheses.
I don't get that rule.
What do you mean?
If we put a bracket or parentheses.
Okay, so parenthesis means it doesn't include that number. So when I had like less than or equal to, those would be parentheses. If I have less than equal to, if I have this, these are brackets.
So when it's a real number, is it always going to be double parentheses?
Well, no, okay, when it's infinity, it's always going to be parentheses because I technically can't get to infinity. So if I told you a number, I'd have a next number. So infinity is always going to be parentheses because it's an arbitrary, you're going towards infinity, you aren't actually getting there.
Okay.
Okay. So now let's do range. Just abbreviate that with an R, just regular R. So range is those outputs, yes? If it was all real numbers, this graph would be going everywhere. Is it going everywhere?
Mm-hmm.
Where's it going? Going
Everywhere. Straight.
up, right? Does it have a bottom?
No. Yeah.
Where's its bottom Y at?
Negative 3.
-3. Where's its top Y at? What's up here? Infinity. So we'll do the interval first because it might be easier to look at. It started at -3 because that's the minimum, and it went to positive infinity, yes? Okay. Is -3 included? Yes, there's no open circle, is there? No. So it's included. Can I ever get to infinity? No. So that is a parenthesis. So then over here on the set, we use y because it's range, such that y is greater or equal to what? -3. Kind of makes sense? Okay, and again, range and domain is going to take a lot of work. We, Cooper and Cole, we work on it all year, don't we? Like every time we get a new graph, I'm like, what is the domain? What is the range? What is the domain? What is the range? Pre-calc, if you go on, what is the domain? What is the range? What is the domain? Calculus. It is something you constantly work at. So do not think you need to be an expert today when you leave class. You just have to have like a little bit so we can start. Am I good? Miles, let me know when I'm good.
Any day
Cal. Only I can harass him about his writing speed.
Me
Thank
too.
you.
Feel on this-
Okay, so here's the picture. I could have given you the picture and made it easy, but we sketched the graph. Did we do it right?
Yeah.
Yeah. Okay. Okay, what is the domain and range of this?
See if it tells you.
Domain, range. Do you guys want to do set or interval first?
You want to start with the little squiggly line, X such that, I know that.
You want to start with that? Okay, good. So that's going to be set notation. And then interval. Okay, again, think about it this way. Where X values are here, yes? Right here? Okay. Can I keep plugging in X values as I go to the left and I go to the right?
Yeah.
Is there any limit on the X values I can do?
Infinite.
No. So it's what? There's no limit. It's all real numbers. Yes? So X such that, and what's my symbol for all real numbers?
Double back R.
Double backed R. So then what does that look like in interval notation? From what to what?
Is it?
From there to there.
Does it matter if the
Minimum first.
negative infinity positive
So negative infinity
parentheses?
to positive infinity. And why is it parentheses?
Because you can't reach them.
Because you can't reach them. Okay.
Range.
Now range are the y's. So you're looking at a graph. Range is so much easier with a graph, guys. So much easier.
So it's 3?
So it's 3, like the max is 3, yes?
Yeah.
And everything else is what?
Below.
Below. So where's my minimum
Negative infinity.
and where's my max?
Positive 3.
Positive 3. So y such that y is less than equal to what?
Less than.
What's its max?
Positive 3.
Positive 3.
Dang, I'm getting smart.
So
And
then we start with the
negative-
minimum,
Negative infinity and positive 3.
negative infinity, and 3. Parenthesis or bracket at negative infinity.
Parentheses.
Parenthesis, parenthesis or bracket at 3. Bracket.
Because it's included.
Because it is included.
Look at that. What I say.
You're so smart.
All I needed was my son.
Okay, am I good? Dakota, am I good? Okay. Okay, a car starts a journey with a full tank of gas. The equation is y equals 16 minus 0.05x. Relates to the number of gallons of gas, y, left in the tank to the number of miles the car travels, x. What are the x and y intercepts? So that's where it hits the x and y axis, correct? Okay, of the graph, of the graph of the equation, and what do they represent? But I want to look first at the equation. So this equation is how much gas is in my tank, yes? So how much gas do I start with? 16 gallons, yes?
Yeah.
Okay, so my graph is going to start at what? 16. Technically, does this graph continue past those x-axis? Technically, right, if I were to graph that equation. But does this stuff matter?
No.
I can't have over 16 gallons of gas in my tank, can I? Not if you have a 16-gallon gas tank. Can I get less than 0 gallons of gas in my gas tank? No. So does that extra stuff out here matter?
No.
Oops, I can't. All this stuff over here and down here doesn't matter, does it? Okay, so we are going to talk about actually the domain before we even start. So our domain, okay, so this is our domain, yes? Here to here. x's, or in this case, miles for m, right? So it's going to be m such that, okay, so what's the smallest miles I can have? 0. I can't have negative miles, can I? No. So 0 is my smallest miles. Okay, so 0. Can I be 0 miles? Yeah, I can travel 0 miles. Not moving, right? Okay, in equal to. Now, what's my biggest miles?
Well,
What's my biggest miles on this tank of gas?
it doesn't
320.
necessarily say that it's a 16 gallon gas tank, Nick. Or are we just saying it is?
Well, we're saying it's 16 because
Okay,
it
it
says,
says
no,
full,
it
okay.
says full tank, so 16. Okay, so on
320.
320. So can I get to 320?
Yes.
Yes. So it would be less than equal to 320. See how we read that graph and got it? But if I just gave you this equation, guys, and didn't give you this situation, you would be x such that it's all real numbers. That's a linear equation, yes? But once we put it in that situation, is that what we have anymore? No. So that's why we have to watch our situation. Okay, so now let's look at our range. Okay, so range, and it isn't y this time because our outputs are distances, so it's what? Not y, but d?
Yeah.
Yeah? Okay, so what's my smallest distance?
0.
0. Oh, wait, this isn't distance, this is gallons. Yes? That's miles. Distance and miles are the same thing. So G.
Still 0 though.
Okay, it's still 0, yes? Okay, can I be 0 gallons?
Yeah.
I'm not moving, but I can get there, right?
16.
So G, and my biggest is 16. And I can have 16 gallons, right?
Yeah.
Okay, so again, situational. Because technically this equation, bless you, this equation, the range would be all real numbers also. Okay, so now let's answer the question. So what is the x and y intercept? So the x-intercept and the y-intercept.
Is that like
So where it crosses the what axis? X. Where does this graph cross the or meet the x-axis? 320. Okay, where does it meet the y-axis? 16. So what do those numbers mean? And we've already said it. What does 16 mean?
Most gallons.
most gallons?
The most gallons I could have. What does 320 mean?
Most miles.
Most miles I can do. We got all that, and we just read a graph. You guys hate making them, but that saved you a lot of math by reading it.
Yeah.
Yeah. Okay. Okay, x and y zero intercepts. We just did them, aka also known as zeros of a function for x-intercepts. So I do want you to make sure when you're writing x-intercepts, you also write zeros of a function. We also refer to them as solutions. X-intercepts, solutions, zeros. It is where the graph crosses or meets the x-axis. How you find an x-intercept is you plug 0 in for y and solve for x. Gail, you gotta write notes. So a y-intercept. Those are not, we do not call them anything other than y-intercepts, okay? That is where the graph crosses or meets what axis? The y-axis. And you find them by plugging in for all the x's, plug 0 in for all the x's, and solve for y. So you'll usually see it as x, comma, 0 for an x-intercept, and you'll see 0, comma, y for a y-intercept, because For an x-intercept, you plug 0 in for y and solve for x. For y-intercept, you plug 0 in for y, or x and solve for y. Okay, so our example, you guys ready for the example?
No.
Oh, okay. You being sarcastic or truthful?
My pen won't write.
Well, then get a pencil.
Crosses the y-axis.
Meets or crosses. Okay, so our example we're going to do is y equals the absolute value of x minus 3. So it says find the x and y intercept. I abbreviate x-intercept x-int. You should label your work, yes? Okay, we're going to do this and we'll be done for the day. So our rule said plug 0 in for y and solve, yes? So that makes it 0 equals the absolute value of x minus 3. Well, it's an algebra equation, so I would add 3 to the other side, yes? Okay, so 3 equals the absolute value of x. Well, what number would give me 3 when I take the absolute value of it? 3 and negative 3. So my x-intercepts are 3, 0 and negative 3, 0. When you are asked for an x-intercept or a y-intercept, you write it as a point. Got me?
Yep.
Okay, so y-intercept, we plug a 0 in for what?
X.
X. So same equation, so I have y equals the absolute value of 0 minus 3. Well, the absolute value of 0 is 0. Minus 3 is negative 3. So my y-intercept is 0, negative 3. Okay? So your assignment is on Classroom under Thursday. Okay? We do have a few more notes to finish, but you have the majority of everything you need. So you work on your assignment as much as you can. We'll come in, finish notes, and then you'll have work time for the rest of the day tomorrow. Good?
Assignment or assigned tonight?
Yes, but finish it. So if you start it tonight, you should be able to finish it in class tomorrow and you won't have homework. Deal?